Everyone. Welcome to our last week of Math 1031. So, this week you're going to be finishing chapter 7, which is all about correlation. And there's not really a lot of Excel work in this chapter, but there is a little bit. So, I'm going to show you guys how to do that in this video. So, I'm going to be going through question 6 on section 7.3, and this will show you all of the Excel work that you'll need to do. So in section, I believe it's 7.1, you will be making scatter plots as well as calculating the correlation coefficient. But in 7.3, you also will be doing the line of best fit and finding the square of the correlation coefficient. So this one question should show you all of the Excel skills that you'll need for chapter 7. So let me go ahead and download this data set in Excel. Awesome. So here we've got this, and oops. So open up the homework and have those side by side. Okay, so first of all, when you are making a scatter plot, you basically just select your data. And whenever you're doing correlation, you're always going to have two variables, and you're looking at how these two variables are related to each other. So once you've selected all of your data, then you just go to Insert, and let me actually make this full screen so you can see it. And under Charts, you're going to select the scatter plot. So you can see this scatter plot here represents this data. Now, the scale of the scatter plot may be slightly different than what's displayed here, because you can see here these axes don't start at 0. So essentially, it's just kind of like a zoomed in version of this. So looking at that, oh, they also want me to have the line of best fit. So let me show you guys how to do that. So when you look at your data set here, you're going to add chart elements and then do a trend line. And for the line of best fit, you want it to be a linear trend line. So if you look at that dotted line right there, that's the line of best fit. So when we look at these charts here, I think this one is the one that's most similar. Yeah, so that's the line of best fit. So that's how you do a scatter plot and make a line of best fit. And then our next step is to calculate R, which is the correlation coefficient, which tells you how correlated your two variables are. So if it's a positive correlation, that means as one variable increases, the other one increases as well. If it's a negative one, it means that they're inversely related, meaning like, let's say in this case, if your brain size was increasing and your IQ score got smaller as your brain size got bigger, that would be a negative correlation. In this case, we can see that it's actually a positive correlation, where as one goes up, the other also goes up, because the slope of the line is positive. But let's go ahead and see how correlated it is. And the way that we do that is with the function correl. So it's CORREL. And then in parentheses, you're going to select your two arrays of data. So you select all of the data for one variable and then all of the data for the other variable. And when you calculate that out, we get 0.328. Now, the correlation coefficient will always be between -1 and +1. So a correlation of 0 means that the two variables are not really related to each other at all. A -1 correlation means that they are perfectly inversely correlated, meaning as one goes up, the other one goes down. And a +1 means they're perfectly positively correlated, meaning as one goes up, the other one also goes up. So in this case, since we have a positive 3.2, we can see that it's positively correlated, which we expected because the line of best fit has a positive slope. But it's not super correlated because this number is closer to 0 than it is to 1. So we would say that this is weakly positively correlated. So the value of R is, they want us to round to 2 decimal places, so we'll make this 0.33. And keep in mind that this number can be negative. In this case, it wasn't, but it can be. And then the R squared value is basically just going to be this number that we calculated for R raised to an exponent of 2, or you can multiply it by itself. So the R squared value should always be a positive number, because even if your R value is negative, when you square it, it will become a positive number. So R squared in this case, if we round to 2 decimal places, is 0.11. And based on our R squared value, that tells us that 11% of the variation can be accounted for by the best fit line. So that's that piece. And then we want to look and see if there's any outliers. And when we look at this scatter plot, we can see that most of the data points are really close together. This one is maybe a little bit far away. So that one is this one. And I already checked the answer before I explained the whole thing. But that one is the outlier because it's kind of far away from the rest of the points. And if we excluded that one, we can see that the line of best fit moves down and R squared becomes larger. So if we remove this data set right there, you can see that the R squared value gets significantly larger and the line of best fit moved down a little bit. I'll put that back in so you can kind of see the difference between those. And then it says, does the line or the best fit line appear to provide reasonably reliable predictions within the range of the given data? Because one of the benefits of having the line of best fit is because it allows you to make predictions as long as you're only looking within the area that the line of best fit covers. So in this case, because my R squared value is pretty small, I would say that the best fit line is not necessarily the best way to predict this. But let's read through our options. So it says, predictions based on the best fit line could not be reliable because the data points do not all fall on the best fit line. Not all data points have to fall on it in order to still be a good prediction. They just have to be close to it. It says predictions based on the best fit line could be reliable because the value of R squared is sufficiently large, but R squared is actually not very large. It's only 11%. So probably not going to be that one. Then it says predictions based on the best fit line could not be reliable because there are not enough data points to make a prediction. And then it says predictions based on the best fit line could not be reliable because the value of R squared means there's little correlation. That's going to be the correct answer because having an R squared value that's so low means that the best fit line is not really reliable for predicting other data values. So that's how you would do question 6. Again, to quickly review the Excel skills, when you want to make a scatter plot, you just select all of your data, go to Insert, Charts, and you click the scatter one. And then if you want to add a line of best fit, you click this Add Chart Elements, and you add a linear trend line. And that's how you make the line of best fit. And then to calculate the value for R, which could be positive or negative, you just use this Correl function and select your 2 data sets. And then if you want to square it, you just take that result and raise it to an exponent of 2. So I hope this was helpful. And if you have any questions, please let me know.